Let's look at different ways we can parse data for data visualization. We're going to start with multiple XY pairs. These data were collected on two different detectors, and you can see they have different starting times for the X data. And even within the X data, the sampling rates and intervals are different. So we're going to use our file converter to import the data. We're going to select on XY pairs and select the CSV file. You may immediately notice that the X data has been interpolated to start with the lowest X value of the two data sets, rounded up to 0.01. The Y data is also interpolated to fit the X data. Now, the tick data didn't start until about 1.4 minutes, so it's just extrapolated backwards to whatever the value was at 1.4 minutes. And then it is interpolated as appropriate for the remainder of the data set. Now let's look at another case where we might have multiple files that have X with many Y. So in this case, we've got two CSV files. The one on the left has an X set of data that starts at 0 and a multiple Y data, and another CSV file with another set of X data. This is time spaced a little differently with 3 different Y data. We're going to use this single X multi-Y importer. So we'll click on that. We'll select both CSV files, holding Shift and click, and we'll click Open. In this case, the importer concatenates both data sets together and interpolates to find a common X data access starting at the minimum value of the two data sets. The final type of file parsing I'd like to show is where we've created importers for multiple file types. And we're continuing to add these as we move along. But in this case, I'm going to show a couple different types of UV-Vis data importers we've created. First is the Beckman DU800, which is a DUX file that is a binary file. And you can see that if you look at the raw data, it's pretty much unintelligible. Next, we're going to bring in a nanodrop tab space variable, or TSV file, that needs some special metadata imports. And we're going to demonstrate this by the drag and drop method. First, we're going to drag the Beckman DUX file over the DUX importer. Can you see the X and Y data has been successfully imported from the binary file? Next, we're going to pull in the nanodrop TSV file and drop that on the appropriate icon. And then finally, we're going to bring in the solo VPE CSV file. And now you can see all the data has been brought in and concatenated to a common X-axis. As you import data, they're added in sequential order. So the DUX file was imported first, followed by the nanodrop TSV file, and then finally the solo VPE file. You can export these to a CSV file if you prefer to import these into another data importer or graphing tool. And finally, when you're done with the tool or you want to start over, you can hit the Clear Data button and it'll reset the app. While we focus today on the File Converter app, all the apps on the website utilize the same algorithms for file uploading. In closing, I'll mention data security and data integrity. For data security, no data is persisted on the server. It's all kept in a temporary file and immediately purged upon closing the web page. And for data integrity, we follow the principles outlined in this NIH public access manuscript on interpolation techniques. Now, interpolation is a very common chromatography and spectroscopy procedure utilized in the industry. You'll find it among a number of different chromatography tools that are utilized by most, if not all, chromatography and spectroscopy vendors.